Hi, this is Don. I have a problem for you that I want to show you how to solve using StatCrunch. And the problem has to do with calculating the confidence interval for the difference between proportions. So how do we do that? Let's see what the problem statement is. And they did an initial survey back in 2007 of just about 1 million students. And that survey indicated that almost 8%, 7.93%, were planning on pursuing an engineering major in college. They did it again in 2014, this time almost 1.3 million students taking the SAT, and 8.95% of those seniors said they were going to be engineers. And we have to calculate the 99% confidence interval for the difference between the proportions. Okay, we can do that the old-fashioned way by using long-established equations. Here's one that I got from Larson's Elementary Statistics 4th edition on page 478. And it's really straightforward. All the values in that equation we can get out of our problem statement. But it is a tedious thing to do, solve by hand using a classical calculator. We can do it much faster and easier using StatCrunch. I'm going to bring up StatCrunch, and I want to enter the data from the problem statement into the spreadsheet. Let's put the total number of observations for the first survey, 999,208, under the very AR1 column, and the number of observations for the second survey, 1,289,612. A lot of people, big N. And our proportion for the first survey is 0.0793 in decimals, and the second survey is 0.0895. So we have our summary data. We don't have the raw data from the surveys, but we've got the summary. Well, let's go to Stat, Proportions, to Sample with Summary. And let's see how that works. Well, we're stuck for the moment. We need to have the number of successes, and what we have is the proportion of successes. So you can grab your hand calculator and crunch that pretty quickly, of course. But let me show you how to solve it using StatCrunch. Go to Data, Compute, Expression. And it's just a simple algebraic expression. We want the values in VAR1 column multiplied times the values in the VAR2 column. And let's put that result in a column, well, I can spell it right, label successes, and hit compute. Okay, now let's go back to Stat, Proportion, to Sample with Summary. Bring that up, and the number of successes in the first trial is 79,237, and the number of observation is 999,208. Second survey, we had successes 115,420, and observations we had 1,289,612. Okay, we're doing a confidence interval, and we want the 99%. Clicking on Compute, we get the results. And we can see in these results we've got the difference between the two samples, and it's negative because the second proportion is larger than the first. It's just about 1%, 0.0102. And even for the 99% confidence interval, which you normally would expect to be very wide, this one's pretty close. Lower limit is 0.0112, rounded to 4 decimal places. Upper limit is minus 0.0093, rounded to 4 decimal places. Well, why is that such a tight interval around this sample difference? Easy enough. Remember the N. The N1, the count in the first trial, was 79,000. That's a large N. The n in the second proportion is larger, 115,000. So that's a lot of power, and that's why this confidence interval is so tight. Well, let's check and see how it compares to the answer. And I'm going to bring it up. There it is. We're right. Minus 0.0112 to minus 0.0093. We got the answer using StatCrunch.